So we're looking at the exergy associated with different forms of energy. We'll now take a look at the flow work, which, if you recall from the open system analysis, is the work required to push fluid out of the control volume. So the work for flow work is equal to the pressure times the specific volume. And so this is the amount of work required to push a unit of mass of fluid into or out of the control volume. And with that, we can rewrite the exergy in the following manner. Subtracting off the work that we might be doing on the surroundings, the P0 term, we then end with the following for flow work. So that is a term for flow work. Enthalpy looking at enthalpy, we know the definition of enthalpy is U plus PV. What we can then do is write enthalpy, or the exergy of enthalpy, as being a combination of the internal energy and the flow work term, substituting in the values for internal energy and flow work, and now I'm going to rearrange this a little bit. And so with that, we can write the exergy for the enthalpy So those are two expressions that we will use when we're doing exergy analysis. And now there are two other types that we want to look at, and that is associated with both kinetic energy and potential energy. So let's take a look at both of those. Starting with kinetic energy. So that would be velocity squared divided by 2. And here, kinetic energy can be directly converted into useful work. Unlike heat transfer, when we looked at internal energy, there we had to go through the heat engine. When you're dealing with a form like kinetic energy, it can be directly transferred, and that's why there is no conversion factor or anything else like that. It's just a direct relationship. So all kinetic energy can be converted directly into work. And for potential energy, again, it's a direct conversion. So we can say that all potential energy can be converted directly into work. So those are different expressions for useful work coming out of different forms of energy. Next, what we'll look at is we'll look at what we can get through heat transfer, work itself, as well as mass transfer.